Okay, just for anyone that's joining us from the recording, we started with just like a brief introduction with like all the like kind of housekeeping stuff, so you haven't missed anything. It was just more so like Google Classroom code, all those sort of things that are already on the website. So if you're watching us some point in the future, just all of that information is in the website. So we're going to start with the math section today. And we're gonna really be focused on algebra. Okay, so when it comes to algebra and the SAT, the most elemental portion of this is being comfortable with solving equations and, more importantly, following steps. Like you being able to look at a question and say, what strategy am I going to use, right? So we have this problem right here. So you can see 1/2 3x plus 14 equals 1/6 7x minus 10, right? Simple equation. So we have two options. The first option is that we can solve by hand. So Tony, do you want to solve it by hand?
Sure. I'll just do it here.
Oh, hold on. Zoom, yeah.
There's the camera. So here we have doing things in parentheses and then we have fractions here. So first I would try to get rid of the fraction. So what I'm gonna do, I'm gonna multiply by 6 so I can cancel out the biggest fraction or the fraction that has the biggest denominator. And then this one I'll have to multiply it by a bigger number, but at least I won't be dealing with fractions. So I'm gonna go ahead and multiply both sides by 6. And so it's gonna end up being 6 over 2, which is 3, so 3 times 3x plus 14. And then 6 times 1 over 6 cancels out, so it's just equal to 7x minus 10. So now I'm gonna actually have to distribute this 3, so it's gonna be 9x. Plus 40, so equals 7x. So at this point, now we just have to add and change the equation to that slate x. So regular. Gonna add 10 here. Just to cancel it in there. So that's gonna be 9x plus 52 equals 7x, right? And then I'm gonna subtract 9x minus 9x. And then what that's gonna leave us with here is 52 is equal to negative 2x, right? So we have to divide by negative 2 to isolate the x. And that's going to end up being negative 26. Right?
Okay.
So that's doing it by hand, right?
Okay, so we did it by hand. So if you're ever solving anything by hand, your goal should be like to start getting rid of stuff around the stuff. So like, see how there's like the x's, you need to isolate x, right? So you need to like, if there's parentheses stuff, try to get rid of that first before you start moving in, right? And then with equations, the most important thing when solving by hand is whatever you do to one side, you have to do to the other. So let's say we want to get rid of that 7x. If I subtract 7x to get 0, I have to subtract 7x from the other side, right? So like, see how he did here, 7x, he subtracted, or in this case, he subtracted the 9 in this case. So 9x, he subtracted the 9x, well, I also have to subtract the 9x on this side, right? So it's a matter of whatever you do on one side, reflecting it on the other, right?
I just want to add that you always like wanna take steps to make everything like to be easier for you, right? So here, obviously, we could have just like distributed the parentheses and like the 3/2x plus 7 equals 7/6x. But those are like really difficult fractions and like. You won't be able to like solve that as fast because like with difficult fractions like that, instead of. When you actually multiply it by a whole number and then it becomes just actual numbers that you can actually work with and do it, you know? So you always kind of wanna see what you can do to make the problem easier for you.
Okay, hold on. Now, let's. Alright. Let's take a look now at how to do it on Desmos. So,
Like clear.
okay, so. That was the first way by doing it by hand. Now, when it comes to the SAT though, you have a limited amount of time, and what we just did was pretty time consuming, right? So. What I think the next. The best thing actually for a problem like this. Is. Alright, so. On the SAT, you're gonna be having access to Desmos, right? So. Desmos, I think, is the biggest. Cheat code for the SAT because. In a lot of cases, it's just going to solve the problems there for you, right? So. Let's take a look at this example that we have here. So. This same problem, right? All we will need to do on Desmos is this. We just need to type it exactly as it appears. 3x plus 14 is equal to 1/6 7x minus 10, right? You plug in the equation as it appears, and then what's gonna happen is you're going to get a straight line. Here it is, our straight line. Once you type in the problem as exactly as it appears, you're gonna get a straight line. You're gonna click on the straight line and see what the value is. So in this case, you're looking for the x value, right? Because that's what we're solving. And you can see the x value where the straight line exists is -26. So for this problem, when they just gave you an equation just like that, you plug it in and you see the straight line and that's your answer. -26, -26, right? So that's the first thing. So on Desmos, you're going to be able to just plug it in and see the answer straight away. And that's gonna say, and we did that in what, in 10 seconds versus like going in, adding, subtracting stuff. Getting the risk of actually, multiplying something wrong, missing a negative somewhere. So for problems like this, Desmos should always be the first choice. And I think for most of the SAT math section, Desmos is going to be your biggest companion on the test, right? So some people sometimes ask, so when should I use Desmos and when should I not, right? So whenever you have an equation, right, they give you an equation of some sort, right? They give you an equation like that, and it's just the numbers and they want you to find x. Or they might use another variable, they might use r, they might use p. I would use Desmos. Now, really quick, so if, let's suppose that instead of it being 3x plus 2, it was like 3r plus 2, right? For you to be able to solve it on Desmos using this, like the method where you just plug in the equation, it needs to be written in forms of x. If like, let's suppose that the problem said 3, like if we changed all of this for like r's, for example. It wouldn't solve the problem because like it's only able to solve, well, r's in this case is something different because that's like a polar equation, but so like if you use another, if you use a for example. It wouldn't give you the line like at all, right? It'll give you an error, right? So it's important that you use x. Even if the problem says 3b plus 2 is equal to 27, you have to use x for it to solve, right? So whenever you have a single variable, like here, we only have one variable and we're looking for x, you're gonna just plug into Desmos, right? Now, there's gonna be some types of problems that are equation focused problems that are gonna ask you in terms of X, Y, Z letters, so in terms of, let's use this example. In terms of P, V, R, and T, solve for N, right? These are what we call literal equations, and they're basically just giving you a variable, right? So PV equals nRT, right? That's the chemical formula, but that's what they're gonna give you a formula for something random, right? And they're gonna tell you, okay, in terms of all the other letters, solve for N. So how can we solve for N here? What do we need to do?
You gotta separate it from R and T.
You gotta separate from R and T. So what is N doing compared to R and T? Like what is it doing to them?
Multiply.
Multiplying. So if you want to get rid of the multiplication, we have to
Divide R and T.
divide, right? So we're gonna divide by what?
R and T.
Divide by R and T. So divide both sides by R and T. And then we'd be left with PB over RT is equal to N, right? That you should do by hand because decimals won't be able to help you out with like a problem that asks you to solve for a single, like, because you have multiple letters, right? But if you have one single variable, then yes, it is completely fair game to use decimals like straight away, right? Why don't you guys go ahead and try this equation that's on there? 3x plus 2 equals 14 minus 2 times 3 minus 2x. And then solve it on decimals and then tell me what the answer is.
It's down there. Right?
It's like when you screen share.
It can be done.
Can you go both?
Yeah.
Okay, so what we would do here. We're just gonna plug in the equation as it appears. 3x plus 2. I can't say. 3x plus 2 is equal to 14 minus 2, 3 minus 2x, and then we zoom out and we find the line. So we can see the line here is -2, right? So whenever you see something, one variable, straight away, like if it was a regular equation, that's your first instinct. There's other, like, so this is just like they ask you like solve for x. Now, whenever you have a system of equations, which we'll get to eventually, I don't think we'll get there today. Those are just like lines you can just graph onto the thing and then find the intersection point. But usually, I think this is the most like foolproof method, right? So, I want to give you guys another practice one for this one, so you guys can try to like solve the equation. So, can you guys solve this equation? Okay, I'm gonna give you the equation. A, B, C over D, E is equal to F, G over A, B, C, D, G, H. I want you guys to solve for B. Right, so that's a multiple step thing. Okay. So how should we start? If you want to get B by itself,
First you multiply by D.
we multiply by D on both sides, right? We want to get rid of the things that are on the bottom first, so we multiply both sides by DE. So that gets rid of that. We bring on this side, so the DE would be on the top, right?
Yeah.
Now, okay, so we're left with ABC is equal to FGD over H. What do we do now to get B by itself?
You gotta divide A and C.
Divide by A and C, right? So if we divide by AC, we can get rid of the A, we can get rid of the C, and we're left with B. And we're dividing, right? So where would the A and C go?
In the
Top or bottom?
bottom
Bottom.
denominator.
So A, C, H, right? So that's basically how you like would solve something like this. What you're trying to do is always like try getting it on its own. So in this case, we have a fraction, right? So you have to get rid of the fraction first. So then you can go on and then get it by itself and then divide the things out so you get just the P that you're looking for by itself, right? Usually for this type of problem, they will give you something simple, I think, in the first section. They might do some constant things, which like that's something we're gonna do like way later, closer to the actual test dates, because like that is the one like algebra question which I think is really, really hard. So we'll like go through some strategies solving that, but for something like this, I would recommend either doing it by hand or you would have another option. So another thing you could do is this would work if you're doing a multiple choice, which for something like this, it would be a multiple choice question. So let's suppose that they gave you like the answer choices, right? So I don't know, they gave you your choices are number one, FG over H. Number two, FGD over H. I don't know, GF. Three, the answer choice actually is FGD over ACH. Or whatever, they give you four answer choices. So what you can do is, since these are variables, you can assign a, let me write this down so I can share it. F, what was the answer that we chose? FGD over ACH, right? So is equal to, right? So here, this. You guys don't got how to like actually solve it out, right? Okay, so what I'm saying with this is these are all variables, right? So we can assign fake numbers as long as they're not equal to one, because since this is multiplying stuff, if you like assigned it a number that's equal to one, then it's like if it was never there. So like we could assign a bunch of numbers, like we could say that, I don't know, where's the keyboard? Here. Okay, we could say that A is equal to 2, B is equal to 3. C is equal to 4. D is equal to 5. E is equal to 6. F is equal to 7.
You said put G.
Oh, whatever. F is equal to 7. G is equal to 8. H equals 9. I don't think they would ever give you so many letters, but whatever. So,
Wait, you might have to change E because I think they think it's 2 point whatever.
oh yeah. Alright. So let's call this. Instead of E, we're gonna use K. Okay. We assign values to all the things that are on there, right? So. This is what B actually is equal to. Now, let's suppose they give you 3 answer choices. Let's suppose they also gave you FDE over ACH. Let's suppose they give you ACH over FDGE. And let's suppose they gave you ACH over FG, right? So now you could also work backwards, right? So they gave you the whole equation that they gave you at the beginning, right? We gave at the beginning. This is what B is equal to. Well, if you set a value for B like we did here, right? We said that B is equal to 3, right? Using Desmos, now we can rewrite all of these. If we could just plug in all our answer choices. So we can plug in ACH over FGD, right? Is that equal to the number that we set for B? See how we set for B? Well, when we set B is 3, right? We said B was 3. Is that equal to 3? No, right? So that's not our answer. You could work backwards and we set a number for each of the numbers and then we plug in. Let's try the one that actually is. FGDE over.
It's K.
Oh yeah, sorry. FGD over ACH. Is it treating F like a function? FGT over ACH. But that's not equal to 3. ACT F H FGT ACH. Did we copy down the right thing? That's weird. We must have I don't know, and we don't have the actual like thing that we use. But if you were to do this, I don't know, we probably made some mistake when we were like copying it down. If you were to like plug in, if you were to set a value for each of the things that like of the variables that you have, and then you like work backwards with your answer choices, eventually, if they're asking for B and you set a value for B, it's supposed to equal whatever the like the right answer is, right? So like once you plug in, if you say that B is 3, right? and then you assign a value to all the other things, and then once you like simplify it out, it is equal to 3, then that's gonna be your answer choice. We'll look through, can you look through the question bank, and then maybe you can find a problem later that we can do this one?
There's.
Is there one there already? Okay, we can try this one. All right, like, let's do this as an example. Morning. Awesome.
Ahora está él sabe que no necesita venir con un informe.
Okay. Awesome.
Bien, no vamos a usar teléfono porque estamos prestando atención. ¿Ok? ¿No? Bien.
Okay. Okay. So let's use this as an example. So 6RS plus T. So first let's solve using the well, the problem is with this, that 6R. Can we move whatever numbers? Well, yes, we can, please. Well, or no. Can we? I know that I've done something like this.
Now that I think of it, or maybe it's like a.
You know, I'm thinking of the different, I'm thinking, sorry. This doesn't work for equations, this works for expressions. So like,
Oh.
if they just tell you, sorry, okay, so. Like, if they just tell you something like. If they give you something like this, FGD equals ACH, and then they ask you what expression is equivalent, you could do this. Ignore what I just said, I'm confused. This, you can do whatever they say, like what expression completely is equivalent, right? Because we have an equation, it means that the variables each have to have a specific value for the equation to be true. So for this, actually, you're gonna have to solve it by hand. When we get to the expressions portion, this is pretty useful, right? Cause like they might give you some weird stuff like, I don't know, 3AC plus D over FG. And then they're gonna give you 3 completely random answer choices, and they're gonna ask you like, which is equivalent, right? Then you can do what we just did, right? The problem here was that we have an equal sign. So you can't have an equal sign to like use them. So. Let's.
In this situation.
Yeah, in this situation. Let's go back and I want you guys, I'll give you guys, there's 5 questions. So this is the first one that we already did, so I want you guys to do questions B, C, D, and E. And I'll give you guys, how many questions? That's 4 questions. I'll give you guys 5 minutes. You see, that's what it was. someone wanna go up to the board and then, show us like either how you plugged into Desmos or if you solved by hand for the last two, how you solved by hand? Javier Garcia,
Oh, the first two I sold them by decimal.
okay, probably who were gonna show us.
The races?
Yeah, you do it, sentence. So the answer is what?
Negative.
Awesome.
Go to the other one.
Yeah, two B. Cause you already found the first one. So, by the way, so if you guys ever get into the position like this where it's kind of like really scaled, you guys can go back to the center, like view of Desmos and you click the home button. Can you click the home button for us? No, yeah. Over there. Awesome. See how it zooms back into like the specific view of like there? Yeah. 1.5. So the answer would be B is equal to 1.5, right? Just simply plugging into Desmos and so do C and then someone else is gonna do D for us. Put a slash. Yeah, what I'm assuming is that the answer choice they would give you here is probably
A fraction.
a fraction. So, okay, here's the other thing, so. Usually whenever they give you, like, if something has a weird decimal answer in Desmos. One of two things. Something like this, I would expect for them to give you like a multiple choice question, but, or for them to get you would get an action and fraction format, right? Sometimes if you solve like this, getting the fraction format might be a little difficult, so then you'll have to work with the answers that you have. To go back and see, okay, like they say they give you, I don't know, 1/2, 3/4, 5/7, whatever, and then you would like plug in the fraction. And then match the number that you have with that number, right? If it's a multiple choice question. And you get something like this, and the answers of course are in fraction format, then. Put the fractions into the calculator and it'll give you the decimal format, and then eventually you should find a match. If it is a free response question. I would say that usually they don't like giving you some weird like decimals. If they give you a decimal, it'll be a
That's
decimal.
happened to me before, like that, it was like fractions and I had to like write in like a decimal system.
Right, but usually like even if you get something like this, it's going to be usually in decimal format, but you might want to get it in fraction format, or they might give it to you in fraction format. So it's a matter of just going into Desmos and then can you press on the keyboard? Like, okay, let's suppose that the answer. Let's see, what's like a weird fraction? 1/8, right? It's kind of weird. It's 0.125, right? So let's suppose that you get an answer choice that tells you, okay, X is equal to 0.125, right? Yeah.
Take it to the side.
Say it again.
If you introduce diagonal the answer, then it doesn't kind of fraction.
It can. Sometimes the weird thing though is that if the fraction that like if the number is like a decimal, even just like one, because like sometimes they'll give you too many decimal places or too little, then what decimals will do is that they'll give you some like weird well, let's check it out. It'll give you some like weird, like I don't know, what like 181 over like 300 or something. Right, if you click, yeah, exactly, if you click this. It gives you the fraction, right? Oh, with something like this, well, let's try it out. Can you write that down? Hold on.
Negative 1.15.
5385.
Yeah, I don't think it's fine. I think it's just like a decimal. So it's negative 23,077 over
Negative 1.5.
negative 1.15385.
Like maybe it is a fraction, right? But like Desmos doesn't like register it if like at this specific like estimation thing, you know what I mean? So like also because of how the calculator does rounding and stuff, it's a little weird. So that's why I would recommend to work backwards. Now, there are situations like this where it's like a direct fraction. It's always it's a simplified fraction, right? Because 1/8, you can see that's like in a pretty simple form.
Oh wait, the fraction is negative 15 over 13. It's just that like it rounded, so if you try to actually like get the right fraction, it's not gonna be right.
Because let's see what they say, like what they negative 15 over 13 or something. So that was the fraction they want you to solve for. And notice how here it doesn't have the 1.5385.
Cause it rounds it off. So like if you would have put that full thing, it would have like put that fraction.
Yeah, so like that's why I would recommend working
Yeah.
backwards and using the answers that you have as a as help. Alright. Do you want to do the last three?
You can do it on the board if you want more space.
There you go.
So here, the way I did it is I multiply by 9 first.
Well, right now.
But then I'll multiply.
Whatever's better here.
So I multiply this by 9. So by 9 forward is same. So divided by 5. Is 32 on both sides. And left it as
Can you rewrite every step so
well,
everything
it's kind of small.
here? Oh,
I don't even know.
I was gonna go through. Click the mouse. By doing it in one of those decimal boxes. Look, maybe that one that has like 25 space.
Alright, so first let's just write this equation out. So
Use the mouse.
it would be D minus 32. Right? So what I would do first is multiply my 9, just to cancel that out. So I 9 on both sides. So,
Okay, now rewrite the next part. So write C times 9.
D 9. then I would divide by 5, just getting out of there, so. Divide by 5. Cancel that out, divide by 5. So then here it becomes sit on the C times 9 over 5 equals that. It's 32, and you just add 32 on both sides, cancel this out. Cancel that one out. And this here, 32. And that should be your answer. So your answer is going to be 8 times 9 over 5 plus 32.
Awesome. So again, it's following the steps, so we isolate the variable that we're looking for. And make it like far more simple. So like, so for example, we see how we have a fraction of things inside of the parentheses. So like with this, you always have to like work your way down, right? So if you have a parentheses being multiplied by something, you first have to get rid of what's outside and you start working your way in as you're starting to like to try to simplify. All right. Delete that and then can you try the second one? The trash can.
But it's by 2, cancel that out, so for 1, pretty much.
The one is just a one.
So only use the 1 step, you don't have to actually worry about that. So it's 8 plus. So then divide by h because you're gonna multiply by h, so it's not good, you divide by h. So that out, you divide by h. So it's a. Back to size. You already have it, so
Those are different.
say, so comes a times a
What happens to the H? Okay, here I would be careful. Cause. Look. This is a problem that like. Okay, so the first part that you did. Okay. A equals 1/2. A plus B. H, right? You have to be careful as to like what you put together and stuff, because then you might get a little tripped up, right? So what you said first is fine, we multiply both sides by 2, so we have 2A, right? Because it cancels this out, is equal to A plus B times H, right? Then we need to get rid of what's outside of the parentheses, so we'll get rid of the H. So we now divide by H, so H, so 2A over H is equal to A plus B. Now, what you need to be careful with is when you write down here 2A, you're going to subtract like the A, like you said, but that's like separate from this, right? Because this A isn't being divided by H. So it would be more so like say 2A over H is equal to minus A is equal to, all right? So it's like that because there is a difference, like this is different than this. It's 2 different things, okay? So that's really important to take note. But that's basically the process. So you see how we worked from like the outside towards the inside, to then be able to isolate what we want, right? All right. if you guys have access to Google Classroom, it should be easier to read these problems. So, if you guys want, we'll do, 3 minutes for both problems. What? Are you clear? Well, we around work here, Julie, just to go to the thing, but, we wanted to see if this was present to you like our script and stuff, but. Well, we have like the tutoring with the 12, so that after that. Well, we're tutoring after 12, so like. Yeah, so then I don't think that would. Interesting about here. Yeah, totally. Yeah. Yeah, we have, like, we've been working. Yeah, we've been working on the testing stuff, so I think we're gonna be fine, so. We'll see. I'm gonna text you some of the local chapter stuff, the scripting for the visuals and stuff. So you can take a look at it. So it's- All right. All right, okay, bye.
Yeah, thank you.
Well, she's not. We can use it like this. Because, you know,
We need to read it just.
no, she's not.
Yeah.
Yeah. Oh. Okay. Oh, he does. He does.
Thank you for knowing. And last year school, she started crying. I was meeting my last year international. I was paying more right, and she was really crying. I felt bad. I gave her the look.
Alright. Who wants to do number one?
We need to go over. I
Oh,
got
you already did one.
Amy.
Amy Douglas. Number one. Okay, here's the keyword. Oh, hold on, you have to look back to page 6. Yeah. So, okay, perfect. That's a perfect example of what I was just saying, that sometimes you're gonna have to go in with a fraction and plug in the answer choice and match it with whatever the actual solution that you found, right? Okay, brief note. If the variable was anything other than y, then it would have given me error. The y works because like it's on the x and y plane. So if you put the variable as y, the only thing is the line, instead of being vertical, it's gonna be horizontal, but it's fine. It's like the same answer. But if it had been like A, B, C, D, E, F, G, another letter, it wouldn't have worked, right? Who wants to do number 4? So it's
I think Carlos always.
Carlos Almonds.
That's the big one.
Step one up.
Nah, bro. Come on, you're not even here, man. Yo, Carlos, you're smart boy. I can't read that. I go there. And read it. You're English. It's like a liberal one. Maybe what we're think about you. I grew up in the desert.
It sounds like a
Woods.
little one, or it just
I
is.
made it like down. It was What? We had like down.
Okay,
One. Oh, finish the rest of it today. The one. I know the answer, but I'm not gonna think.
well, you already, does no one else wanna go? No? Tony?
I shall. Okay, so. I'll read the description. It says a student score at, so I'm gonna start highlighting variables. So a student score S is determined by the given formula, so. Where C represents the number of correct answers and I represents the number of incorrect answers. So, which of the following expresses I in terms of C and S? So our like final product expresses I. So our final answer should be I equals and then. So. Gonna first start with this equation that they give us. Like right. Like this.
Oh, sorry. Yeah, you can.
Oh,
That's as far as it goes.
okay, yeah, that's it. So. So, first. Already. That's. minus 1/4 I over C plus I, right? So it's kind of complicated because what we're trying to solve is I, but it's on both sides of the fraction. So what I'm gonna do, I'm first gonna multiply the denominator on both sides to kind of get rid of the fraction, and I'm gonna try to see what I can do to get all the i's on one side. So first I'm gonna multiply C plus one, so it's gonna be S times C plus one. And then that's equal to C minus 1/4. I'm sorry, this is I, not one. And then minus 1. So I'm gonna distribute this so I can like start combining like terms with the i's. So I'm gonna do SC plus SI, right? So I'm distributing that S, multiplying the both terms, right? So that equals C minus 1/4 I. Right? So now what I'm gonna do, I'm gonna try to get all my terms with I on one side. So I'm gonna try to get them on the left side. And then, so since we're gonna try to get all the i's on the left side, I'm also gonna try to get rid of what doesn't have an I. So first I'm gonna subtract SC because that doesn't have an I. So minus SC. Minus SC, right? And then I'm also gonna add 1/4 I on both sides. Because that will help me put all the items. So that's something out, that's SI plus 1/4 I equals C minus this. From our streets, we write it. That's. I over 4. Equals. And so. What I'm gonna do now. On both sides of the equation, I'm gonna try, well, first I have to factor out I. To just be able to divide everything else that isn't I and just get I like as it is. So I'm gonna factor out I because it's in both terms up to the left side. Now, like when you actually put all the terms with I on the left side, I can just do I. And then put a parentheses, multiply it by S. Plus 1/4, right? Because if I distribute that, it's gonna become SI plus I over 4, which is exactly what it is, right? This is just an equivalent form. And then it's equal to C minus SC. So now I have this I here, so I'm going to divide by S plus 1/4. And that's gonna leave the I alone on the left, right? I'm gonna write that on both sides, obviously. And then my answer is I equals C minus S. That's C plus. So obviously that isn't any of the answers, so I'm assuming that it's going to be in a different form. So I'm gonna try to start like changing it around. So we have two options, we can start changing it around, or what we can do. We can just use decimals on the thing we were doing earlier with like putting random numbers and then see if they're equivalent. Because it can be really, a lot of work to try to get it in.
Let's see.
What?
Let's see.
Oh. Okay, we just move on.
Yeah. Alright. Let's do this, so this shouldn't take that long, we have like. 20-ish minutes, and I wanted to get to the next part, cause it's really important, so. Let's. Can you guys quickly do at least, do the top two? To these, to do like number 3 and number 5.
Which there's no one on this Zoom.
You know, I don't forget that we're doing the recording. Or really, like recording the one on 3.
Oh,
Nice.
so you want to do that, we just record like
No, like.
them alone. On the, or like teaching kids on them.
Yeah, like, it was just sitting on.
So we.
So what do we need to do for these 2 problems?
What tool?
What? I can hear you. Desmos, there you go. So we use Desmos to solve both of these. So we have this first one, for that first problem, actually for both of them, what do we need to do first? Or we plug into Desmos?
Change that to X.
Change them all into X's, right? Because they're not anywhere to work. So 7/8. 7/8. X minus 6. Is equal to 21/2. Okay, so then we zoom out. $18, right? So then we get 18. Yes, sure, awesome.
Pretty simple.
No. That's all right. This second one, same thing. We plug into decimals. 4 plus Z minus E plus.
Remember to change the X.
Oh,
Give them a S18.
the good thing about decimals is that like you'll realize like when you've already done, you put it in, like it just sucks because you have to like go back in and change it out. But like the good thing is that you can sort of like then something like this. If I was like all the day on the test, the thing is that this is kind of hard to use. It depends. If you either have a mouse or you can just like drag your finger.
It can be very difficult to do on the Chromebooks.
Yeah, it just depends what you take the test on.
Yeah.
If you ever need to put a big, let's say you have a big expression on top like this, so like put a fraction over this whole thing, you can do it. Of course, not this will work. No, you have to put in the fraction earlier. Right. Minus 3 times 5 2 7 we zoom out. There's your answer 61. All right, so that's basically Desmos using for plugging equations like that. All right, this next part I think is really important. It's basically how do we read a word problem and then find what we're asking us, right? So as you can see, actually solving the equations with decimals is actually pretty simple because all you have to do is just plug in the equation. Now, the more difficult part, I would say for some people, is you get a word problem now. How do we write something out from here, right? So it's a two-step process. First, we need to turn whatever we have into an equation, right? So that's where reading the problem carefully comes in, right? So this problem, for example. A laser tag arena sells 2 types of 1-year membership. Package A costs $325, unlimited number of visits. So we pay $325, we can go as many times as we want, right? Package B has an enrollment fee of $125, includes 5 free visits and costs an additional $8 per visit after that, right? How many visits would a person need to use for package B to cost the same as package A, right? So the most important thing here is we need to think about relationships in terms of y equal mx plus b, right? So what is this formula giving us? Our y is going to be our total value, right? So this could be, you could use various examples, right? I'm gonna use the example that I think makes a lot of sense. This also makes sense with some things we're gonna do later on. Let's suppose that you're running, right? You're running, right? And you're saying, okay, my speed is 5 miles an hour, so that's gonna be your slope. Slope times your distance plus your initial. So you say, I'm running 5 miles per hour, right? I started the race 2 miles ahead from my friend, right? So that's the initial, right? Then your slope is gonna be the miles per hour, so whatever the per hour thing is going to be whatever goes with your slope, right? So let's suppose that we're using this running example, so let's say that you run 5 miles per hour, right? And you were 2 miles ahead, so our total is gonna be the total miles ran, right? So if I ran for 2 hours, how many miles did I run total?
Um,
12, right? Because we plug in the 2 for the number of hours. And we get 12, right? So this is how everything's related, right? So your slope. So if you have y equals mx plus b. Your y is going to be your total. Total measured in whatever your per thing is. So for example, if you're saying per hour, right? In hours, or sorry, the miles, so like the total miles, if you're doing dollars per hour. Dollars, your y is gonna be measured in whatever the part before the per is, right? Right, so if they give you in this case, per visit, and we're talking $8, your total is gonna be measured in dollars. Right? Then. Your slope, your m. Is going to be the rate. Which is the number that is tied to the per, right? So, for example, $8 per visit, that means that our slope is going to be $8. Right? Your slope is just the rate at which something grows, so if I say something like, okay, I earn $8 per hour, so that means that every hour I work, I'm gonna get $8, so it's gonna be growing by $8 every hour I work, right? In this case, every visit you go is gonna be worth $8, so that's gonna be your slope. And your B is how much it was initially, right? So this is gonna be, for example, in this case, if you have a one-time fee, right? Or, if you like, usually for this type of problems, I would say it's like usually like a one-time fee based. I don't know what else, like what other examples we would use.
Like an enrollment fee, maybe like. Or like population, flat fee, like.
A flat fee, right? So like here in this case, think about it like this. No matter if you go once or you go 10 times, you still have to pay the $125 in the beginning, right? So now let's break down this problem that we have here. So the first one, it's simple. They tell us we pay $325 and we get what they want us to do. How many visits for package A to be equal to package B? So package A is simple. $325, you don't pay anything else, that's it, you can do how many times you want. So that's just easy, so that's just $325. Package B is a little bit more complicated, so we have a $125 initiation fee. Which includes 5 visits. And then every visit after that is worth $8. So. What you need to do, how do we set up this equation? What would be our formula here?
So.
It would be 325 equals 8x plus 125.
8x plus 125, right? Now, I'm gonna say a little caveat here. So if they just say a one-time fee that says like a one-time fee that includes no additional visits, this would be the answer that you solve. And whatever you get for x is going to be your result, right? Now, because X represents a single visit, we need to be careful though, because if we solve for this, we're solving as if we don't get those 5 free visits from the beginning. So, you have 2 options. You could say, okay, after the first 5 visits, so whatever you solve for X here, you have to add. So like, for example, if you find that X is 3, after we plug it in, the total number of visits, it's the 5 free ones plus this, right? Or sometimes they're gonna ask you to rewrite the equation using using this and saying, okay. So it's 8x plus 125. Or because the first 5 visits are free, each visit costs me usually $40, right? So from that initial fee, if you just say, well, it's still 8x, right? But you take away the $40 those first visits would have cost you, then you would get here 85. No, yes. 85, right? From the $40, no, sorry, that's wrong. No, never mind, it's right. 40. 8x plus 85. Right? So. Do you guys get why there's a difference? Because this one that has the 85, we took out what the $40 would have been for the 5 visits that we got for free, and we put them now into here. So now when we count up from like 1, 2, 3, 4, 5, it's the actual number of visits. Whereas here it would be whatever X is plus the 5 visits that we got for free that we need to like take into account, right? So if we're to solve the equation on decimals, what would be our answer? For how many visits would it be for that to be equal? How many? 30 visits?
Just follow it. Yeah, it's fine. Yeah, fine.
Well, which one do you use this one or this one? Because if you use this equation like here, right? If you add the full 125p, then you have to add the X plus 5p.
Yeah.
If you use it in this format, it's the same thing, but you don't need to like add the 5 additional visits because you already factored them out by the way or stuff.
But it's 25 plus 5, which they.
Yes.
I probably would have skipped the 5 previous.
Not with this one, you gotta pay for this.
Yes, so that's where they actually get you, I think, with these questions, is that like, they'll get like that 5 free visit
Yeah.
thing.
Just
That
like they add
changes-
random stuff.
They add random stuff, so you need to make sure that you're reading carefully, because you see how that changes the problem, right? Because I would have honestly like, I think the first couple of times I did a question like this, I totally would have, I skipped the portion of the 5 free visits, but that actually counts, right? Even though that they're giving to you for like a flat fee, you still should factor in into like how many actual visits it would take you to pay it off, right? So that's the big difference here, but that is kind of like this problem being a little bit on the harder side of this type of problem. What they want you to do is to be able to break down, okay. What does Y mean, what does the slope mean, and what does the y-intercept, right? So to do that a little bit better, I need 2 different problems here. Alright. Let's try number 1. A gardener charges a one-time fee of $10 and then $15 per hour worked. What equation models how much the gardener makes? That's our first question, and then how many hours were worked if the gardener made $70 in total? So how would we write our equation? So we want to inform y equals mx plus e, right? So what's if we deal with this first part, we don't know why, that's what the equation's telling us. the one-time fee, is that M or is that B?
B.
B, right, so we add the 10. What's our per hour rate or slope? 15, so it would be 15x, right? So whatever has a per hour is going to be a slope, right? Or a per whatever is gonna be the slope. And then the one-time fee is always gonna be your y-intersection. Alright, so this answers our first question. How many hours were worked at the garden made $70 total? So the $70 in total, what would that be in this equation?
Why?
The y. So now we can solve. 70 is equal to 15x plus 10. Which gives us 4. Okay, try this one. A bag contains 2 types of items, a red ball R and a blue ball B. If the red weighs 2 pounds and the blue weighs 3 pounds, what equation models the total weight of the ball of the ball? Of the bag, sorry.
Oh. Yeah, so. Two R plus 3, or no, 2R plus 3B equals,
The weight.
guess what? Wait. W.
Equals the weight, right? So with these type of problems, what you need to do is read whatever they're giving you, because what they'll also do is that they'll throw multiple variables, especially once you start getting into system of linear equations. What you need to be able to do is pair the right variable with the right slope, right? So here they're telling us that the red weighs 2 pounds, so we need to put the 2 with the R, right? If it tells us that the blue weighs 3 pounds, we need to put the 3 with B, right? So with the modeling the problems, it's reading and making sure that the pairs that you make are the right pairs, and then remembering, of course, that the y gives you the total, the per whatever, the number that comes before that is your slope. And the one-time fee is going to be the $10. Another way that I've seen them do it is like they might give you a money problem. They love giving money problems for this and then for like exponential growth. If you start the amount of money that you have at the beginning, right? At the start of like when you open the account, that's gonna be your B, for example. Or I've seen them doing like days after, right? How many days after did XYZ happen? When does time start? 0, right? If like there's no time before 0, so 0 times 0 is whatever you had at time 0 is going to be your y-intercept. Alright? Alright.
And
Try this one. After a couple dances for 3 hours in a charity dance-a-thon, they earned $50 per half hour of additional dance. Additional dance. Assuming they dance for at least 3 hours, which expression represents the total number of dollars earned by a couple who dances continuously for 8 hours? C? Why is it C?
Because you have to take up the first 3 hours because they're dancing for free. First 3 hours.
Okay, but,
Where does it say that?
well, that's fine, but. Read this carefully.
For half hour, so 100. So.
Thing per half hour, right? We wanna know what the rate and what the equation would be for a full hour of dancing, right? So our slope isn't 50, what's our slope for 1 hour?
100.
100, right? And we know that they dance for free for the first 3 hours, so. It would be D, right? 100 times every hour of dancing, so if we dance 6 hours, right? That would be 100 times 6, minus the $300 that we would take off that we didn't earn for dancing those first 3 hours, right? So for something like this, it's recognizing, okay, those 3 hours that we don't dance, that's like 3 hours we don't earn our slope, but we can still write it. Using like the slope for the 3 hours, the slope for the hour, which is 100 each. If you subtract whatever you don't earn, so that way, because the other thing here is that they tell us that the couple dances for more than 3 hours, that's important, because like once you dance more than 3 hours, then. This equation will be true, right? If you dance less than 2 hours. This wouldn't be true at all because. No matter if you dance an hour or 3 hours, we don't pay anything. And we don't have to pay them back, right? And we're not earning money because it hasn't been more than 3 hours. Alright. So. Let's leave it here for now because we have to like switch to the other room. Like today took us like a bit longer than I was expecting, so we'll be doing these same problems next time we see each other.
Remember, this is gonna be posted on the Google Classroom.
Yeah, it's already on Google Classroom, and then next time, like, we'll get through these problems, I think are a lot easier, because it's just like breaking stuff down. And then. Next time we'll get into like graphing, things like that, so we get more comfortable with like, again, what Y, M, X, and B mean, so, yeah, so we're gonna go ahead and switch to the other room, and then, let me see if they're ready for you.
I think they are, Kimberly came and asked. What? Get back to that feeling. 9:58. I didn't know that was so bad. I have to get my break. I think that's great. That's what they were wanting there. We want to be there instead of. They're like. And so. The reason this one is small, you know. That's actually what. They're provided, oh yeah, I'm like, no, actually, we're not Disney. Really? I don't know what we. Oh, the only event, don't turn me with that, because I'm looking for you, don't turn me with it. Huh?
Okay, I think we can start moving now.
We're smoking.
Huh? It's on the teacher.
Wait, we're switching over.
Yeah, we are. Okay, so guys, Fiona, get up and move over.
I don't think. We're. No, I don't know. Something's up, like what?
I should.
I try not to think about those things. Yeah. Like,
The vending machine still work?
I think they sort of stopped it, yeah, because there's like apps and people.
The bar.
Okay. Maybe something hot, say that's my, I'm not sure.
Okay.
So, do you have to move us or something?
No, we're already here.
Good.
Okay, hey guys, how are you?
Hey, everybody.
Let me hold on, quickly fix this. All right, so welcome to the map section of today's tutoring. Let's start here. While we get this set up, can everyone like just say their name and then what school you're from?
Yeah.
We'll just go in the order that we see here, so we'll start with Sahara.
Hi, my name is Sahara. I'm from International Studies Charter School.
Alright, now Sergio.
Hey, I'm Sergio. I'm from Merit Academy.
Krishna.
Hi, I'm Krishna. I'm from Matter Biscayne.
Hope.
Hi, I'm Hope and I'm from Cornerstone Charter Academy.
Reina.
Hello, I'm Reina and I'm from Pinecrest Lakes High School Preparatory School.
Aaron.
I'm Aaron and I go to Pinecrest.
Awesome.
Ellen. Is that Ellen? Elias.
Yes, Elias.
Oh yeah, Elias. Sorry.
My name is Elias and I go to Slam Boca.
Awesome.
Carolina.
What?
My name is Carolina and I also go to Matter Biscayne.
Cool. Evelyn Gonzalez. Evelyn. That's fine. Mariana Teixeira.
Hi, I'm Mariana and I go to Somerset Academy Chapel Trail.
Catherine.
Hi, I'm Catherine. I go to Somerset Academy, Chapel Trail.
Hi. Oh, okay. Sophia. We switched to reading.
Hi, I'm Sophia and I go to Our Lady of Lords Academy.
Icebreakers. Andrew.
We have to spell.
Hi, I'm Andrew and I go to International Studies Charter High School.
Evelyn.
Into a main room and help them.
Hi, I'm Evelyn. I go to Matter.
Salima.
Hi, I'm Salima. I go to Pinecrest.
The
Okay, guys, change of plans. I'm really sorry. We're gonna go back to the breakout room really quickly. Hold on. So go back to the breakout. The breakout room should be open. We'll go into the breakout room and then I'll move them out to the main room because we need to record their session. Give me just a second. And then Anthony, I'm gonna click here. Can you click back there and join the breakout room? Like you join the breakout.
in participate.
Go to more. Oh, well, it's whatever. More.
So beautiful. There?
Yeah.
Alright. Everyone, please move to the breakout room.
let's have the girl who's matching with me in the back, because I also have green. What's your answer? And if you didn't pick one, we're gonna have beef.
Yo, if she gets it wrong.
No.
What'd you put?
Please don't.
You put B?
Yeah.
Okay, so that is incorrect. I'm gonna hand this up. Do we want to hand it over to Lewis? Do we want to trust him?
No, I don't.
Okay, we're not switching Lewis. Okay, so it is not B. And I'm not even sure that you guessed that like right now, but that's okay. We're gonna go over how to approach it a little bit. Lewis,
It's actually B.
can you explain why?
Because two for shorter distances and spend more time.
Yeah, that's the answer that I asked. Okay, so hey, asked you why, not what. You gave me the what. Okay, so we're gonna actually go over this question right now. Okay, so I'm gonna show you how I would approach a question like this, because when you see inference questions, there are like two main types. There's gonna be like the really long, like paragraphy ones. So I'm talking like this, and they're gonna be very scientific. So they're gonna give you these random names, like I'm not even gonna try to pronounce that. That to me looks like cactus or whatever. I'm not even gonna try. And then sometimes they're gonna give you like a graph, a table, a chart, something visual for you to see. So in a case like this, your main like combatant is time. Your main enemy is time. Okay. So what I'm gonna do? Well, when you see terms that are very scientific, you want to kind of draw your own connection. So if it says Cretaceous, Tertiary, dino, it's a dino, it's a dinosaur. Okay, and we see that because the star. We don't have to worry about that right now. T navigates. Okay, you're gonna see that this is too long even for the test writers themselves. So they're gonna shorten it later on. I'm not going to be reading that every single time that I'm reading this paragraph because it's going to take more of my time and I need time for the SAT. So I'm going to literally say T, am I right? You can just like skip over the name if you want, but sometimes they have two. So sometimes they'll have T navigans and they'll have S navigans or whatever. So I like to give them little letters, so T and S, T and whatever, just so I know if they bring up like multiple different animals later on that I'm not like getting them confused. So the dino T is known for having an anomalously oversized head crest. Okay, so it has a really big head. Until, whenever you see words like until, although, but, however, you're going to want to make a mental note of that because it's telling you that something's going to be shifting, something's going to be changing. And that's important because sometimes here, when they ask you for the actual inference part, they're going to be asking you about the first part, about the second part, or about the change itself, right? So if they're asking you about like, oh, the new observation suggests what? You're going to want to ignore the first part. And you need to know when that change is happening. So, until. An almost complete fossil skeleton was found in Brazil. Paleontologists, these are just like people that study dinos, you don't need to know that, but so you know, had been able to study only skull specimens from T, though it was presumed that, like other pterosaurs, this species' primary form of locomotion was powered flight. Okay, so again, these are like really big words, right? You don't really need to know what locomotion means, but you see motion, you think movement, okay? And it says powered flight. So what is this saying? This is saying that before, we only really knew about his head. We knew that he had a really big skull, a really big head, okay? And then it says, that these scientists assumed that like other dinos that were in its little family, right, that it could fly. That it could fly and that's how it moved mainly. So it says primary form of locomotion. So how it mainly moved was flying. Okay? Okay. Again, it says until. So examining the fuller skeleton in 2016. So now they don't have just the big head. Now they have the whole body. Victor Riccardi and his team, random scientists, we don't care about him. It's gonna be team. They found that he had long hind legs, short wings, and an unusually long neck. These are all descriptions. So from here to here, it's a description. Characteristics that, combined with the creature's large crested head, would have made sustained flight difficult and walking upright relatively difficult. Okay, why is this important? All these characteristics that it's saying, the big head, the short wings, the long hind legs, whatever, this is important only because it's now saying, okay, so if this dinosaur were to fly, it would be very difficult for it to fly. And actually, walking upright would have been a lot easier for it. So the scientists before, they were thinking, okay, well, you know, like the rest of his little family, you know, he flies. But now they're saying, low-key, maybe he doesn't fly, or maybe he doesn't fly much. It seems like that'll be really hard. And you don't, you know, I'm not sure about you guys, but I'm like pretty lazy. I wouldn't want to do that if it was hard for me, right? So he's gonna walk. Based on these findings, so again, these are recent findings. We don't care about this first part. The team suggests that T likely link. Okay. So, I'm not gonna ask you guys like for the answers because we already had an answer and it was B, and I'm gonna explain that now. But so, flew for longer distances than did other pterosaur species. No. The reason that's a big no is because we already found here that it said flight was difficult for this dinosaur. Why would you fly longer if it's harder for you to fly in the first place, right? So we can already take out A because it directly opposes our claim. And what we care about is what supports this later part, not the first part. Okay, had longer wings than other pterosaur species considered da 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 da. Okay, you know why I didn't read that last part? Because A, it says it has short wings, okay, and B, there's nothing about a comparison between its wings and the wings of any of its family members. So that right there is a big no. Okay, so C and D. So C had a smaller head than researchers expected based on the earlier Navigant skull specimens. How do we feel about that?
Absolutely not.
Okay, yeah, A said it had a big head, and again, like longer wings, whatever, like it wouldn't really contradict itself. And then B, did it mention anything about it having a smaller head than earlier specimens? Did it even mention comparing different dinosaurs? Different skulls, different anything? No. So based off process of elimination, the answer is D. If you're on a time crunch in the SAT, you're gonna select D just because you know that the other three are wrong, right? But if you have time, maybe I'm gonna go back to your answer, if you flagged it or whatever, you're gonna want to see if D actually fits what you're being asked. So what does D say? Flew for shorter distances, okay. If it's harder for you to fly, you're gonna fly less. Common sense. So that first part checks out. And spent more time walking. If something's more comfortable for you to do, you're gonna spend more time doing it, right? Okay, well it says that walk out part was good, so that second part works. Then researchers previously thought, yeah, because they thought something else before, and now they changed their minds. So that's why these are answered. Do we have any issues with that? Any questions on that? No? We're good? Okay. Kim? Anyways.
Just break my phone.
Okay, how about it?
Hi, Abraham.
Calm down.
Hi. Okay.
It's okay.
You probably already did that question. Oh, we
Yeah.
are. Okay. Okay, it doesn't matter.
Oh, you put that one. Oh wait, no, that's not it. Do the regular annotations and just very tell a lot. Just picking up questions that we didn't do last time, like the other index questions. Okay.
Okay, okay. 18. Again, as you start seeing, like with any question, doesn't even have to be inferences, you're gonna start seeing a pattern in the questions. So inferences is always just gonna ask you what choice logically completes the text. Okay, so you can skip your time in, reading a question because you already know what's expected of you. So unless you can obviously tell that in this blank you're gonna have to fit a boundary or like a vocab word or a phrase, with grammar in it, it's always gonna be inferences, okay? So you can just disregard that. So that's our reading. Consumer psychologists have theorized that people who identify as ethical consumers, okay, and these people, it tells us right here in these M dashes, that they're essentially individuals who purchase goods and services if they have a positive or just a neutral outlook on if this product is going to impact society for the better, for the worse. Okay, these individuals are never going to buy a product that they think is morally incorrect. Okay, ethical. Think of that. Ethical morals. So individuals who identify as ethical consumers will purchase a given product if it positively correlates with their perception of its effects. Again, you're not going to purchase something you think is bad for the environment. Okay, these are what ethical consumers believe. In a recent study, these ethical consumers were studied over a specific phone, okay, and they found that on average, the study participants in their 20s rated the phone's social and ecological effects much less positively than did other age groups, participants in other age groups. Okay? All other things being equal, if consumer psychologist theory is correct, this finding suggests that. Okay, so what we've read is that consumer psychologists, they theorize that ethical consumers, which are people that only purchase things if they see it right, it's kind of repetitive, they'll only purchase a product if it positively correlates with their perceptions. okay? And then this was tested with a phone, and these participants that in their 20s rated the phone's social and ecological effects much less positively than did other individuals. So what does that tell us? These individuals are ethical consumers because right here it tells us that, they take into account social and ecological effects, and these participants rate the social and ecological effects of the phone. Okay, so we can tell these 20s are ethical consumers. Easy. Okay, so let's start with A. Do we think it's A?
No.
Why?
I mean, they never actually compared it to other phones in the market, they only compared it to other ethical consumers in different age groups. So our answer has to consist of the fact that it's in other age groups, not different phones.
Absolutely. There was no similar phone mentioned. Why do we care? We don't care about another phone, we just care about this one that we're seeing. And these individuals are seeing that it's not that favorable towards society or the environment, so we're not gonna buy it. They're much less likely to purchase this. No phone is mentioned, so don't just assume. Obviously, we could assume that, okay, maybe they didn't wanna buy this phone because there's another phone that's more beneficial, but it doesn't say that, so never assume, okay? A is not correct. B. You think B is correct?
Yeah, because since they rated it less, they have like a less chance of actually buying it because they didn't like it as much as the other age groups.
So B could be it. What about C? Anyone else other than Lewis? No?
It's not talking about if they're gonna be like a meaningful purchase for them.
Right. So honestly, C is an automatic no. Usually there's like two answer choices which you can like automatically say no. C would be one of them, okay? Because we can see here there is a meaningful difference. These individuals that are in their 20s, they're much less positively likely to purchase these products based on how they feel. So there is a difference, okay? It's not like, if they would have just said that these individuals in their 20s were, more likely, well, they were about the same likely to purchase this than the other age groups. No, they were much less positively impacted by this mobile phone. So there is a meaningful difference, okay? So C is not it. There is a meaningful difference, and you can tell this is like the key phrase. Okay, D. Ethical consumers in their 20s are more likely than ethical consumers in other age groups to consider a phone's social and ecological effects when deciding whether to purchase that phone. What do you think?
So when it comes to that, the SAT when you actually try to make it that complicated on purpose, they do try to trick you sometimes, but when it comes to these types of questions and inferences, the simpler the better. So normally if there's two options that both sound kind of good, then the simpler one is always gonna be the answer is more concise. So the SAT kind of just testing you on it's not testing you specifically can you decipher what the hard one means? It's more of do you know what the text is trying to tell you and can you fill in the blanks? So it's gonna be the simpler one, so be the answer. And so he's just too wordy for their team to be it.
But if that was too wordy, okay.
Okay, but other than too wordy, let's just go back to the paragraph and see why it's not D. Okay, because yes, we can assume it's too wordy. Yeah, it is really wordy. But let's just see why it wouldn't be it. Because maybe you're stuck between B and D and you can't differentiate other than the fact that it's too wordy. And let's back it up with a little bit of evidence, Okay, so it says that ethical consumers in their 20s are more likely to purchase a product than ethical consumers in other age groups. Okay? They're more likely to consider, not purchase products. They're more likely to consider the effects when seeking to purchase this product. Okay, so obviously, it doesn't say that these individuals in their 20s are ethical consumers, but we can, again, infer that because it tells us that individuals who look after a social and ecological effect of a product they are ethical consumers, right? So that's why we placed, the title of ethical consumers to these 20-year-olds, okay? But then it just tells us participants and other age groups. It has nothing of these participants being ethical consumers. It doesn't say anything. It doesn't give us not even a clear name that says these other participants are more ethical consumers, or it doesn't say that these other participants also take into account these social and ecological effects. They don't. So we can't just assume that these other participants are also ethical consumers. If it doesn't say it, again, don't assume. If you can't come back and underline it or get a keyword that would point you to it, it's not it. Okay? So yes, it's not going to be this because there is no discussion of whether ethical consumers in other age groups, would be less likely than the participants in their 20s to think about any effects of a phone's purchase. Okay? So in this case, the answer would be B. Okay? And it's obvious. We can come to this passage and we can underline the parts of B that correlate. Okay? So much less positively, less likely. Right? That right there is kind of a given. Okay? Again, don't just click it because, okay, you have the two words and, sounds right. No. Read all the answers through, but let's say you were in a time crunch. This is most likely going to be your answer, 9 times out of 10. Okay? Perfect. Okay, that was the one.
Alright. I'm gonna breeze through two of the, so we have them split by difficulty, right? I'm gonna breeze through two of the easy ones for you guys because I don't wanna spend too long on those as opposed to like the medium and hard. So for the warm-ups, we don't have the answers and whatever because these are from like official SAT practice tests. But then we have the following set of questions. We have a lot for you guys, on the actual PowerPoint that you guys can choose to do at home for practice, whatever you want. We're gonna go through a few of them today, but not all of them because we just don't have the time. But each of them has, so they're by difficulty, so 1, 2, and 3, and they each have the answers and the explanations from the SAT themselves. Okay, when we get to, you're gonna see in the easier questions, you're gonna be okay, the explanation's a few sentences, it's good, whatever. When you get to those difficult questions, guys, the explanations are yay big, and that is no exaggeration. So why am I telling you this? They're good, but they're gonna be wordy. They're good, but they're gonna be wordy, and sometimes they're harder to understand than the actual question. So if you have any specific questions on what we're covering today, I would suggest that you ask us or come to us after or something, as opposed to relying on the explanations because they can get they can get very hard to understand. So I just want to prepare you guys for that because they're an extra resource for you guys that we wanted you guys to have and be prepared. But they're not the easiest thing in the world to use. So okay. We have these. Obviously I know that this is not ideal and technology is not cooperating right now, but what? Okay. But you're gonna have to bear with it because alright. And then this one unfortunately does have the work that we did for last time, but I'm gonna go over one with you guys that's brand new, so it's not gonna have any of this stuff, which is hopefully gonna make both of our lives easier. Alright. So I'm gonna be going over the actual question with you guys, and then I'm gonna ask you guys what you think about the question, same thing as Kimberly, and we're just gonna do the expression like that. So again, this is difficulty 1. So microbes that live in shallow lakes and ponds produce methane. Okay, I want to signalize something really quickly. Whenever you see, so last time we saw a hyphen, okay, not a hyphen, an M dash, comma, parentheses. In inference questions, these are probably going to be definitions. Okay, why do I signal that? Over here defines methane. So this is the definition for methane. It doesn't say it here, but then it describes it and then it says called water milk oil. Over here, comma. We're describing what duckweed is, okay? I'm signaling this out because if you're in a time crunch, a lot of the time you can afford to skip these definitions. I'm not saying skip every comma or anything, but I'm saying if you see a very specific term that then has a comma, a dash after it, they're probably going to define it for you because they don't expect you to know this. Again, they're not testing you on vocabulary, they're testing you on how you can make inferences, how you can draw conclusions. So just keep that in mind because if you're in a time crunch and you're really stressed about time, more likely than not, that's something you can skip. So microbes that live in shallow lakes and ponds produce methane, a harmful greenhouse gas. That's just describing what methane is. Ecologists, they're always gonna bring up some kind of expert, scientist, ecologist, whatever. Half the time, their name, not relevant. They're just gonna bring it up later on so you know who's saying it. Half the time, it doesn't matter. So this ecologist and his team wanted to show how different types of shallow water plants might affect the amount of methane that escapes into the atmosphere. That's important because that's what you are trying to find. So that's what the study, that's what the findings, that's what everything is related to. That's good because it's going to help you sometimes eliminate answers that are just completely unrelated to the study, to the findings, all that jazz. So his team, this guy's team, set up water tanks with soil and microbes from local ponds. Some tanks have a type of underwater plant that grows in soil called water milfoil. So again, this is the definition for that. Other tanks had either duckweed, defined as duckweed, a type of plant that floats on the water surface, or algae. Abe and his team found that tanks with duckweed and algae released higher levels of methane than tanks with water milfoil did. So right off the bat, we know from the study, from the findings, that something about water milfoil is going to lower the amount of methane that we have. Okay, why? Because the tanks that just had this, they still had high levels of methane. They had higher levels of methane. But whatever had water milfoil, something in there is drawing that methane back. So keep that in mind. So what does it suggest? Okay, again, inference questions. That's going to be a time waster. Every single time, the question is going to be what most likely completes the text. So whenever you see the blank, focus on this. This is what they're asking you. This is the real question. Okay. So A, the presence of some kinds of underwater plants like water milfoil helps prevent methane from escaping shallow lake spots. How do you feel about A? Does anyone feel like the answer is A? Not A? Problems with A? Do we not understand it? Anything? You say no? Okay, why do you say no? I'm going to be asking you guys for reasoning, and that's not to say that you're right or wrong. It's just so that we kind of see like what you're thinking, so I can help you through that.
The methane escaping. Like,
Girl, speak up.
I'm trying to like
I think
figure
it's
out how to
careful.
explain it. So, like,
Okay, we're going to come back to A. B. Shallow lakes and ponds release more methane than deeper bodies of water because shallow bodies of water usually have more plants than deeper bodies of water do. Very wordy answer. How do you feel about B? Y'all, can we get some like activity up in here, like a little more passion, I don't know, a little more energy? It's like 11 a.m. Be for real. Okay, so I was seeing like at least head nods, head movements, so I'm gonna actually go with that. I agree. It's a no. Guys, I want to signal this to you because it's a really wordy answer, but there are words right there that you could have just said, okay, that immediately makes my answer wrong. So what makes the answer wrong? First things first. Deeper, shallow. This is all comparing shallow water plants, shallow bodies of water. There is no mention here about deeper bodies. We're not comparing deeper bodies of water. I don't think we even mentioned the word deep in this entire thing. And if we do, it's not relating to the actual pond itself. Okay, so that right there, wrong, because it's something completely unrelated to the study itself. And then over here, because they usually have more plants. So this is their reasoning. Right off the bat, there is nothing about their finding. There's nothing about like their study itself that talks about the amount of plants. It's talking about the types of plants. So it's saying duckweed versus algae versus water milfoil, whatever. Nothing in there says, oh, having 50 duckweed versus 100 algae. No numbers. If there's no numbers, it doesn't say more than, less than, greater than, whatever. We eliminate it. Because this is completely unrelated to the study. Okay, so let's see. Shallow lakes and ponds are more likely to contain algae than to contain either water milfoil or duckweed. All right, I'm seeing actual answers this time. Good. So no, I completely agree. There's nothing in here about probability. Nothing says more likely, less likely. You know, chances are nothing in there at all. So again, you guys did pretty good on that. So let's try D. Having a mix of algae, underwater plants, and floating plants is the best way to reduce the amount of methane in shallow lakes and ponds. I'm seeing no's, but I'm seeing like less sure no's. You look a little confused. Your eyebrows are like furrowing.
Sorry. Is it wrong because it's the mix of them?
Okay, it's wrong because. Okay, so I'm gonna first signal like the specific word. So best. Whenever you're seeing an inference question, you're gonna want to stay away from absolutes. So if it says always, never, best, worst, because a lot of the time, if you're drawing an inference, a conclusion, it's because you don't know. It's because you don't know if this is a yes, a no, 100%, a 0%, right? You're somewhere in the middle, which is why you have to kind of guesstimate. That's what an inference is. An inference is a guess, an educated guess, but a guess, right? So if this is saying this is the best way, there's no comparison here. There's nothing here that says, okay, this is 100% tested and proved. This works better than da da da. No. The other thing, having a mix da 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 is the best way to reduce. There's nothing here about reducing the amount of methane, right? It's saying that the ponds that had this, released higher amounts, but our goal in the study isn't to bring that number down. We're not finding what works to reduce it, we're just saying that the tanks that had this produced less methane, right? But we're not trying to find a way to reduce it. So this has a different aim than the study that we're actually talking about. So A is wrong. So we come back to A. Since A is the only one that we didn't automatically eliminate, again, if you're in a time crunch, you automatically pick A because that's the answer that's left. But let's quickly talk over why A is right. So A is right because the tank that had water milfoil had less methane. Okay, so what can we assume? So some kinds of underwater plants. So this is good because it says some kinds. So we're not limiting it to just water milfoil. There could be a random like lily pad out in like Lagos or something that also works for this. We don't know. This is good because it tells us that the scientists aren't sure, which is why they're doing this study in the first place. So this wouldn't be an inference question if it was 100% certain or 100% sure. So that's good. That tells us that they're uncertain. So that means that, okay, we're not going for absolutes. We're not doing 100%, 0%, worst, best. That's good. Helps prevent methane from escaping shallow lake and ponds. Does that support the finding? Yeah, it does, because the finding is saying that the tanks that had water milfoil had less methane than the tanks that had duckweed and algae. So something in that water milfoil is reducing the methane. Do we get that? Do we see how I brought that from the findings? More importantly, do we see why the other answers are wrong? All right, and do we see how, because this is the main thing that I want you guys to understand. Specific terms, so deeper, best, these are the kinds of like quick things that you can just say wrong. And I just kind of want you guys to get like used to that, because for a lot of these questions, what makes them a little difficult is like the time, trying to solve them under time. So again, you look at this cute little explanation, it's pretty quick, it's simple. You're not going to see this when we get to difficult questions. The difficult questions, yay big the explanations. So again, great resource, try to ask your questions while you're here, okay? I wanted to do this one with you guys as well, just because I feel like this one's a little more, this one's a different type, so this one's less scientific than the other one, okay? So in their book, let me get this little thing. In their book, Smart Pricing, Jagmohan Raju, and again, they're gonna bring out names that are like probably gonna be very difficult for you to pronounce. Don't worry about it. And John Jang consider musicians' use of non-traditional pay-as-you-wish pricing model. Okay, so they're talking about this. We can probably assume what that means, but they're probably going to define it later on. And they define it now. This model generally offers listeners the choice to pay more or less than a suggested price for a song or album, or even to pay nothing at all. So the definition for this, again, they don't expect you to know these things right off the bat. Okay, so they are exploring this type of model where basically people choose how much they pay. As the authors know, that's the option most listeners chose for an album by the band Harvey Danger. So people liked this type of model for this band, okay? Only about 1% opted to pay for the album, resulting in earnings below the band's expectations. So only 1% paid, and the earnings were below their expectations, okay? Let's check this. But, so again, there's gonna be a shift, something here's changing. The authors also discuss musician Jane Silbury, so this is different from that one, who saw significant earnings from her pay-as-you-wish model. So significant earnings. So in one, we have pretty low bank, and on this one, she's making a pretty good amount. From her online music store, as a result of many listeners choosing to pay more, so these listeners want to pay more, as opposed to the 1% that opted to pay at all. Then the source suggested prices. Hence, the pay-as-you-wish model may blink. So again, this is the exact same cookie cutter question. We can ignore that, or we care about this part, so this last line. So okay, A, prove financially successful for some musicians, but disappointing for others. How do you feel about it? Do you think that's the answer? Do you think that's not the answer? Why? I'm seeing a no over here. Do I see any yeses? Do we agree with her? Do we think it's a no? I'm seeing a lot of nothing. I'm seeing a lot of stone-faced. I want a little more action. You're very smiley. What do you think?
I think it could be an option.
Okay, it could be an option. So we have leaning no from Miss Girl over there, and we have a maybe. Okay. B, hold greater financial appeal for bands and for individual musicians. Okay, we're not thinking that far, right? We're trying to use the information in the text, right? I mean, it's good that you're drawing connections like that, but you want to kind of think of what's right here, okay? So right off the bat, I just want to tell you guys about B. The reason that we don't want to go for B is because it says, first of all, there's no kind of like, it's it's like too broad, right? Because we're using one band and we're using one musician and we're automatically assuming bands are going better than individual musicians. So first things first, it says all. So it's going for like bands. So bands in general, so most bands, most individual musicians. We can't get that from just one like study with one musician and one band. That's the first thing. The second thing, the actual conclusion of the study showed that this band made not, they made like nothing because only 1% paid it all. So everyone got their stuff for free, okay? And then over here, the individual musicians, so over here, Jane Silbury, she made bank, okay? So this, like, not only is it going too broad, but then we're also directly contradicting what the study said. So that's a big fat, yeah. And like, guys, sometimes you wanna like, again, picture these things like in a real world, in like a real world scenario. So like, if you are a strong fan of like Rihanna, and like you really want to support her, you're probably gonna pay like $20 for her album, even if she says you can pay nothing because you want to support her, because you want her to come out with good music. Are you gonna give that same support to Pepito on SoundCloud? No, you're not, because you don't care about Pepito, right? You care about Rihanna. You want to support her. You want her to come out with pretty banger music. So, like, guys, think logically, right? See, because most musicians who use the model to lower the suggested price of it, there is nothing in here about lowering. There is nothing in here that says, oh, this would probably suggest that most musicians want to lower da. There's nothing about changing prices. Nothing here talks about changing any prices. It talks about real results that for one musician we got this, for one musician we got that. We're not changing anything. So that's right off the bat wrong, because we don't get that from the study. D. More strongly reflect differences in certain musicians' popularity than traditional pricing models do. How do you feel about that?
Although it could be true, it's probably not, just because it's talking about financial stuff, so.
Okay.
Rather than B, or than D.
Okay. So.
It's not false either, it just has less to do with the actual text.
Okay, so I like that he mentioned that, right? It's not that this is outwardly wrong. It's not that this is the wrong answer, like wrong, like as in, like outwardly it contradicts the text, it goes against, no. But it's not the best fit. Why is it not the best fit? There's no real direct data that says that it reflects differences in popularity. Now, obviously, we think of it as, okay, one band is probably not super popular versus Jane Silbury that a lot of people want to support her. Okay, we can assume that. But at the end of the day, this is about using the data that we actually get from the findings. And the data that we get from the findings is that over here, we had one musician that made bank, we have one that made zero. So, we're going to want to lean towards A, because what does it say? Well, it says that it proved financially successful for one of them, and it did. For Jane Silbury, she made tons of money. But for some, it's disappointing, and it was. For Mr. Harvey Danger, I don't even know what that is, but yeah. So see, so it's not that one of the answers, again, if you're in like a situation like this, it's good that we already got the 50-50, right? So we already eliminated B and C. So that means you went from a 25% chance to a 50% chance of getting the right answer. That's great. Those are great odds. But we're looking for the best answer, and the one that makes most use of our data is A. Okay. Do we see why we got A versus like D? Yeah? Good. All right. Amber D. So she's gonna do medium, and then we're gonna do like harder questions at the end. Oh.
I'm
Oh,
sorry.
Did it wipe the writing?
I cleared it.
Oh, okay, guys,
Maybe
we're learning.
that's the method. Okay. Okay, so this is like medium difficulty. So I'm gonna do 2 of these, and then maybe we'll do like 2 or 1 of difficult, and then we have like, yeah, we should have time for that. Okay. So again, forget the question. It's always gonna ask the same thing. Let's start reading. In her 2021 article, doesn't matter when, the name of the article, doesn't matter. So let's just start here. Scholar Ann Gardner discusses John Johnson, okay, and then it tells us when he, like when he died, when he was born, doesn't matter. So Ann Gardner discusses John Johnson, who is a devoted collector of items intended to be discarded, including bus tickets and campaign pamphlets. Johnson recognized that scholarly institutions considered his expansive collection of ephemera to be worthless. Okay, right off the bat, I don't know what ephemera means. Do you guys know what ephemera means? You do? What does ephemera mean?
It goes away. It exists and then the second it doesn't exist. It's just
Right. Okay, so let's just say you didn't know what it meant at all, you're
Okay, wait, quick note. So I wanna just point out something, so that's the definition of ephemeral. And why I wanna say that's good is because if you don't know the exact word, you can use similar words to find out the answer. So ephemera refers to little objects that are meaningless, temporary, stuff like that, right? But if you know the definition of ephemeral, like she does, then you can use that to figure out what the definition of ephemera means, okay? So again, you're gonna wanna be making these webs in your head.
Alright, but let's just say we don't know what that word means, because I really didn't. You can just use the passage. You see that these are items intended to be discarded, they're worthless. We see an example is a bus ticket, campaign pamphlets. So we see ephemera are just trinkets, little gadgets, little objects that are not as valuable, they're not really significant, they're not that important, okay? So again, his expensive collection is worthless. But it wasn't until he died in 1968 that Oxford University's library acquired his collection because they saw the potential value, okay? So they acquired his collection. And that's what this paragraph says. So, recapping it. Anne Garner is just, discussing John Johnson, who was a collector of items, and throughout his life, up until he died, no scholarly institutions ever thought that his items were, significant, they were worthless. But when he died, after he died, Oxford University specifically just saw that there is value to his little trinkets, to his ephemera. Okay? So now we have to complete the sentence. Hence, the example Johnson serves too. Let's start with A. Demonstrate the difficulties faced by contemporary historians in conducting research at the Bodleian Library without access to ephemera. What do you think? No. What do you think? No. Don't be scared. Why do you think no?
Because he had access to them, and I don't know. I don't think so.
You just don't think so. Okay, that's fine. A wouldn't really be it, okay? Because what they're telling us now is they're not really telling us that researchers could or couldn't conduct research with or without ephemera. They're just telling us that they thought it was worthless and now it's valuable. Okay, it's just two different things. They're not telling us that, oh, it was worthless because they could never conduct research with it, but now they're starting to conduct research with it, so now it's, valuable. It doesn't mention anything about that. There was just a sudden shift, okay? So if anything, we'll come back, but we don't think A is the correct answer. Again, there are no difficulties faced by these historians because they're not really telling us, how these historians are using ephemera. They're not telling us how it's used, why it is or isn't significant to us. It's just telling us that once it was not significant and now it is, okay? So it doesn't say any specifics about difficulties that they faced, none of that. Okay, B, represent the challenge of incorporating examples of ephemera into the collections of libraries and other scholarly institutions. No. Why do you think?
Because it doesn't talk about any topics that goes to just so that they don't want it.
Right, so clear cut. It's also this is gonna be very repetitive, but clear cut. And actually, this could be one of the answer choices that if you didn't have any time or if you really didn't know how to go about this question, you might choose this answer. Why? Because okay, they do tell us examples of ephemera. And you know what? They tell us that it's bus tickets and campaign pamphlets, so I think that's the answer. No. Okay? Absolutely, they are showing us examples of ephemera. Those are the bus tickets and the campaign pamphlets. But they're not telling us that there's a challenge. John Johnson himself didn't go through challenges to try to get these into these libraries or scholarly institutions. It just said that it was worthless. He couldn't get them in because they deemed it worthless. And then after he died, it's valuable. Okay? So there is no challenge. There were no challenges either by John Johnson himself or by other scholars, later on, or by Anne Gardner. There were no challenges. Okay? Let's just say no for B. Okay, lend support to arguments by historians and other researchers who continue to assert that ephemera holds no value for scholars. What do we think? Do you think this is like a maybe? Would you probably pick this question? No? Why not?
Because after like in the last line they remark that they find value in these things. So
Right, yeah, that's it. So they do find value in these things, okay? There was a shift, at first they didn't. So if this answer choice would have said that, it lends support to arguments that ephemera does hold value, this would be the answer choice, okay? But they're saying that ephemera holds no value. If we were saying that ephemera holds no value, we would only be catering to this part in the passage, okay? When they don't mention that it has, grasped the potential value, okay? In this answer choice, there is value to ephemera, okay? So we can't say that we're continuing with this belief that there is no value because we've changed that belief. We did have it once, but no longer. We do think that there is value in ephemera, okay? So this would not be the answer choice. Now D. So the example of Johnson serves to illustrate both the relatively low scholarly regard in which ephemera was once held and the later recognition of ephemera's possible utility. Do we think D could be it? Yes. Why yes? Okay, absolutely. It's supported by text. We start off with, okay, ephemera is worthless. John Johnson's ephemera is worthless. So it was once held at a low scholarly regard. And then now we're recognizing that there is value. After his death, there is value. And this passage it shows both sides. That, we once believed that it was, worthless, it didn't have no value, but now we do believe this. For what reason? It doesn't really matter, okay? We just have to recognize that John Johnson's example just shows us, show the reader that ephemera has now the two outlooks, two perceptions to it, Once it was worthless, now we value it, okay? So do we still think A, could be an answer choice, or do we think it's D? Do we think A still makes a little sense, or do we think D is the correct answer choice? D? Wonderful. Yes. Okay, yeah, so this one, very good. Okay, this one is again one of those questions that, kind of bores you because I don't really care about these scientific names, I don't really care about this bird, but we just have to push through it, forget about the names, forget about these animals. Let's just see what they're telling us, okay? So let's read it. Songbirds learn to respond to and imitate their species' songs from an early age. With each generation, small differences are introduced that result in distinct variations, called dialects, among geographically isolated populations of the same species. Okay? There's small differences, distinct variations and dialects, isolated populations of the same species. a study examined whether 12-day-old birds, okay, bird nestlings, prefer local dialects over the unfamiliar dialects of non-local bird populations, okay? Let's just, I'm not gonna read all that, let's just replace this with bird. Okay, this has become bird. Okay, the more begging calls the nestlings made in response to a song, the stronger their preference. Okay? So this study, it just tells us, it's seeing if these birds prefer local dialects or unfamiliar non-local dialects. Okay? And that more begging calls the nestlings made, the stronger their preference. Okay? Researchers found that the nestlings produce more begging calls in response to their own dialects than to non-local dialects. Okay? So more calls to their own dialect than to non-local. Since song preference plays a role in songbird mate selection, the findings suggest that. Okay, what did we just read? Before we go on to the answer choices, what did we just read? It was a lot. It was kind of like the same thing, repeating non-local, local. What did we just read? Okay. The first sentence doesn't really tell us much, okay? So we can, skip over that. Let's go to here, a research study. So we're just looking to see whether these birds prefer their own local dialects from their environments, or if they actually prefer non-local ones from, an isolated population of their same species. Okay? Then we see here, okay, so that's what the study is trying to examine. Then we also see here that the more calls that these nestlings make in response to a song, the more they prefer, the more they prefer this type of dialect, I guess. Okay, so let's say like more calls is like, stronger dialect resonance. Okay, just say something like that. But then again, it just tells you more begging, it's just stronger their preference. But then again, it's stronger to their preference to what? A dialect. Okay, whether local or non-local. So that's what I mean by this. Okay. Researchers found that nestlings produce more begging calls in response to their own dialects than to non-local dialects. So what does that mean? They strongly prefer that. They're more likely to resonate and to call to their own dialect. Okay? So since song preference plays a role in songbird mate selection, the findings suggest that. Okay, start with A. Bird nestlings' preference for their own dialect likely disappears as they mature to promote socialization between different bird populations. Let's see. Do we think A is correct? Do you think it could be a maybe? Are we lost? A little bit. Was it too much? Louis, you got me?
Yeah, very good.
Yeah, there you go. If anything, we can come back. We'll come back. Okay? Just keep that in your head. B. Bird nestlings who show an early preference for their own dialects are likely to receive more food from their caretakers than nestlings who show no preferences among any bird dialects. What? I mean, what food? Are we talking about food? No. We're talking just about calls, we're talking about dialects. No food is mentioned. Just because a bird prefers some dialects more than the other does not mean that they're going to receive more food from it. That's one that you can clearly just cross out. That's incorrect. Okay? Absolutely not. C. Bird nestlings' preference for their own dialects likely drives them, when they mature, to reproduce with other birds from local rather than non-local populations. What do you think? Listen, if you search it up, don't say anything. What do you think about C? No. We're not talking? Okay. So we don't think C is it. Okay. So let's say we'll leave it as a contender, but we don't think so. Okay, what about D? Bird nestlings show a preference for both local dialects and the songs of other local songbirds over the songs of non-local birds of any species. Is that confusing? That's a little confusing to me too. Okay, and this is basically just telling us that these birds are showing a preference for their local species and for other songs of just birds that are around them. Do we ever discuss other birds, other songs of other birds? No, we've only ever discussed local, non-local of the same F something species, okay? So I wouldn't say it's D, okay? Maybe you could see how like the words get wrapped into you, maybe you could be like, oh, okay, I really don't know D, okay? But we never really discussed any other song from any other bird over the songs of non-local birds. Okay, maybe if you just totally cross this out, this could be it. They do prefer local dialects over non-local dialects, but it's not of any other species, it's of their specific species. Okay? Do we understand that? Do we get it? Are we so confused? With D, are we confused with D? Okay? Just fact of the matter is, they don't mention any other bird species. So the fact that this answer choice is talking about songs of another bird, we never mentioned that, okay? So it can't be the answer. Okay, so we said C and A. Let's get back to A, okay? The bird's preference for their own dialect likely disappears as they mature to promote socialization between different populations. What do we think? Is this talking about socialization? No? Why do you think no?
Because it's mostly talking about when they were little kids and they're like in their own local groups. It's only talking about them socializing with other groups.
Okay, and then we see, mind you, you always have to use obviously the big paragraph, but go back to the sentence that they're asking you to finish. What is that sentence? Since song preference plays a role in songbird mate selection. What are we talking about? We're talking about mating. Okay? So what does socialization between different populations have to do with mating? Okay? Maybe you might think, oh, they become more friendly, this and that, but they're not talking about mating. They're not talking about, they're not talking about any like intercourse or something like that to be very, descriptive. Okay, so I'm gonna say it's not it. Okay, let's look at C. So these birds have a preference for their own dialect that drives them when they mature to reproduce with other birds from local rather than non-local populations. Let's go back to this little paragraph. We see here that nestlings produce more begging calls in response to their own dialect. What does more begging calls mean? That they have a stronger preference, okay? Kind of like sketch it out. But they have a stronger preference for their own local bird population, okay? Then if we're saying that song preference plays a role in songbird mate selection, then wouldn't these birds be more likely to reproduce with those who they feel more familiar with, those who are, who their begging calls are in higher rates as opposed to like a non-local population? Absolutely. These birds are gonna, okay, so when they introduce to you the fact of birds from an early age, just think of it as this. These birds are being, raised or in the environment of these other local birds from such an early age that when it comes time to reproduce, they're already so familiar with them, which is why they start calling them more than they would to non-local populations, okay? So, what else? Right, so let's see. Do we have any questions? This one's annoying, okay? It's definitely just like all the wording that, gets tricky. Okay, but do we have any questions? Are we not like, who would not pick C? If you took this test right now and you got this question, who would have not picked C? Melvin, root of all 50. Alice? Okay. And root of all 50. Okay, guys, if you have questions, please don't. Or maybe I'm gonna show you like the College Board explanation right now. Maybe you can read it then, okay? Read it a little bit.
Alright, again, this is gonna be posted, I do have only like 60 minutes to go over. I wanna try and do 2 questions, realistically, we're gonna get through one of the hard questions, but that's okay. Again, this is all gonna be posted, so like you guys shouldn't have like too many issues. I wanted to also show you guys really quickly before, that's an example of like a hard question explanation, right? Like, they're gonna be pretty hard, like they're gonna be pretty long, this one's not bad. But like the majority could have these crazy long explanations. So like again, it's a good resource. Don't get super used to it though. Like, be for real. Alright. On to this one. Am I already ready? Yeah, okay. So this one, as you can see, is like level 3. Fair warning again, this is all from the official SAT question bank. These are SAT questions that have come out, like they have IDs and everything, like this is from the SAT College Board, so make sure that like you're not glossing over these, like if they're like a random book or whatever, like this is from the company that makes this test, so you're gonna wanna make sure that you are actually understanding what we're going over, okay? So, one theory behind human bipedalism speculates that it originated in a mostly ground-based ancestor that practiced four-legged knuckle walking. Let's take a pause right there. Okay? One theory. If I tell you right now, one person thinks that blue is like the best color ever, right? You're probably expecting something along the lines of but, or like however, another person thinks X, Y, and Z, right? A lot of the time if they say one theory, if they say one scientist speculates, if they say da da da, it means that something's gonna contradict that later. So just keep that in mind. You're gonna wanna know how the SAT kind of thinks, right? So one theory behind human bipedalism. Again, this is another word that they don't expect you to know, so they're gonna kind of define it for you throughout the text. So over here, we're talking about four-legged knuckle walking. Over here, we're talking about moving upright on 2 legs. I'm gonna get to that later. But if I'm approaching this, and in the first like 2 seconds, that's the word I see, I want to already be thinking of what do I know that's similar. So if I see the prefix bi, right? So think like bilingual, bicycle. That means 2, right? If I see pedal, right? Think of the pedal of a car, the pedal of a bicycle, right? It's where you put your leg. Okay. So this is somewhat related to 2 legs. Just keep that in your mind. So one theory speculates that it originated in a mostly ground-based ancestor. Okay, just a term that I want to keep in mind. That practiced four-legged knuckle walking. Okay. So we have this theory that bipedalism, which we don't yet know what it is, but we have an idea, originated from someone that lived on the ground, from an ancestor that lived on the ground, and that did knuckle walking on 4 legs, like chimpanzees and gorillas do today, and eventually evolved into moving upright on 2 legs. So this right here, moving upright on 2 legs, we can assume that then this is what it's referring to when it says bipedalism, because it says originated, then it says it evolved into this. So it's saying this is what bipedalism is. It's moving upright on 2 legs. Okay. So this is one theory. One theory says they started on the ground, they were walking on 4 legs, then they evolved to go on 2 legs. But recently, again with the but. So again, something here is contradicting. Researchers observed orangutans, another relative of humans, standing on 2 legs, so they have bipedalism, on tree branches. Are tree branches on the ground? No, tree branches are connected to trees. They're high above, they're in the skies. So this kind of contradicts this, and then we're gonna keep going. And using their arms for balance while they reach for fruits. Okay, so that means that modern day orangutans, right, they use the same bipedalism that we thought came from the ground, but they're using it on trees. And it's helping them. It's helping them to reach these fruits that they otherwise wouldn't be able to get. So it's helping them. Keep that in mind. These observations suggest that, again, we ignore this. This is the real question. So what does this suggest? Okay, let's look at A. Bipedalism evolved because it was advantageous to a tree-dwelling ancestor of humans. How do you feel about A? Maybe, okay. I'm seeing a lot of maybes. Do we hear like a why? So why do we think it's A? Not Lewis. Anyone else? Can we get one from Miss Gray Sweater in the back? Because I think you're kind of out of it right now. A. Any thoughts? Any questions? Anything? No, yes, yes, no? Yeah, this girl's clocked out. Blue. I feel about A.
I'm kind of divided because it's only mentioning the tree part of it, and it's also mentioning like the crowd.
Okay, good. So we're at an A. Let's come back to that. Let's check B. Bipedalism must have evolved simultaneously with knuckle walking and tree climbing. How do you feel about B? Okay, see, I'm seeing furrowed eyebrows right there. Okay, Miss Girl right there, she just gave me the. You know what that means? If you do that on that test, that's a no. Okay, if your initial reaction is immediately, what are they talking about? That's a big sign to you that something, whether you realize it or not, is going wrong. So I'll tell you where you like kind of was like what? Simultaneously with knuckle walking. There is nothing in that entire passage that says in the 1900s they knuckle walked. Nothing. They don't talk about time periods. They don't talk about developing at the same time. They never mention time at all. They just say, you know, there's a theory that it went from this to this, right? That's as close as you get to a timeline. They don't give you a timeline. So simultaneously, that word right there, if they didn't have this and they say evolved with knuckle walking and tree climbing, you could be like, okay, maybe. Simultaneously, makes the answer wrong. So let's check C. Moving between the ground and the trees would have been difficult without bipedalism. Again, I'm seeing some eyebrows. I'm seeing again, if these are your initial reactions, that should already kind of tell you something, right? Even if you can't explain why you think it's wrong, something about that answer is throwing you off. So in this case, right, there is nothing here that says, okay, A says moving between the ground and the trees. It says that this species first is a mostly ground-based ancestor, okay? Do we care about whether they move on trees or not? Do we care about what they do when they go on trees, or do we care about how difficult it is for them to go on trees? No. We just know that this species was mainly on the ground. And we know that this species, orangutans, in modern day, are mainly in the trees. There is nothing about switching in between them. There's nothing about whether it's difficult either. A lot of the times, like SAT is gonna want to throw like difficult. It's gonna be more difficult. It's gonna be easier. It's gonna be simpler. A lot of the times, there is nowhere near enough evidence to even like remotely say this is harder, this is easier, this is. So right off the bat, we can take out D. So let's check D. A knuckle walking human ancestor could have easily moved bipedally in trees. How do you feel about D? Okay, so Ms. Bill over there is already giving me signs, right? Over here. Okay, mostly ground-based was the one that did knuckle walking. So what do we care about a possible knuckle walking human ancestor that moved bipedally in the trees? If they're knuckle walking, they're moving on 4 legs. So right off the bat, if they're knuckle walking, they're not moving bipedally. They're moving with 4 legs. And if they're moving in the trees, then they're not knuckle walking. This is like contradictory because you can't do one, you can't knuckle walk if you're moving bipedally because one takes 4 legs, one takes 2. And last time I checked, we're talking about monkeys, not an octopus. Okay, so D is out. So again, if you're in the middle of the test and this is the question that you get, you're gonna go with A because it's the only one that you know is not wrong. But now I'm gonna tell you why it's right, right? So first things first, it says bipedalism evolved. Okay, well we know that it evolved because it was advantageous. Why is that word important? Even if you don't know what advantageous means, big advantage. So something about bipedalism is helping you. Over here it says that current monkeys find it useful when they reach for fruits. So it's helping them reach their fruits because they need to balance, okay? To a tree-dwelling ancestor of humans. Well, if it's advantageous to monkeys nowadays, that probably came from that same ancestor to humans, right? Then it was probably helpful to the same tree-dwelling ancestor of humans that those monkeys also came from. So if it's helping them now, it probably helped them in the past, which is why it evolved to be helpful in the first place. So that's why it's A. Do we get why it's A? And do we get why it's not B, C, or D? Yeah, good. We have 7 minutes. Do you guys want me to like try and speed through another question, or do we all like a mental break? Because I know that probably a lot. I mean, let me see if there's another that I like TPH. We can probably speed through one. Okay, we can do this one. This one's quick. Because I want you guys to have like more exposure to like the hard questions because sometimes they don't look initially as hard, but the reason that they're hard is kind of like the wording and the structuring of the question. So let's look at this one. Researchers recently found that disruptions to an enjoyable experience, so again, this is over here. Sometimes it's not a direct definition, but a comma is sometimes giving you something to help you out. So in this case, it's like an example. So like a short series of advertisements during a television show, comma. So this is the end of the example. Oh, 20, well, whatever. Often increased viewers report enjoyment. Can you put it up for 20? So often increase viewers reported enjoyment, okay? So some kind of break in between what you're watching. When you're watching something good, is gonna increase enjoyment, okay? So suspecting that disruption, so an unpleasant experience, would have the opposite effect, comma. How many of you watch like Love Island? This is a genuine question. You watch Love Island? Okay, you're the one that's gonna get this reference, right? If I say right now, right, suspecting that Hannah's man would be free, could have voted better out, right? That means that whatever came after that comma is being done because we think that the first part is true. So that's what's happening here. So this next part of the sentence, whatever it is gonna be under the assumption that this first part is true, okay? The researchers had participants listen to construction noise for 30 minutes and anticipated that those whose listening experience was frequently interrupted with short breaks of silence would thus. I know that was a lot of words, but what's it saying? So it's saying that thinking that disruptions to an unpleasant experience would have the opposite effect. So what's the opposite of increase? Decrease. Okay, so we're expecting something to decrease. What are we expecting to decrease? The reported enjoyment. So we're expecting them to be less happy with these breaks, okay? The researchers had them listening to construction noise and they gave them breaks. So basically, what are they saying? So basically, they're saying, what would you think would happen if we're expecting a decrease in enjoyment and we're having them listen to construction noise for 30 minutes and giving them a break? Okay, so what choice would logically complete the text? So let's see A. Find the disruptions more irritating as time went on. Do you think A is right, wrong? I'm seeing a lot of maybes. And you said what?
Say probably, just because irritating is the opposite of like increasing enjoyment.
Okay, so I saw mainly maybes, but Lewis says yeah, so we're gonna lean yeah for now. Okay. B. Rate the listening experience as more negative than those whose listening experience was uninterrupted. How do you feel about B? So this is saying, so the first part is saying that when there was an interruption in something they liked to watch, then it actually increased their enjoyment. So if this is saying that there was an interruption in something they didn't like to watch, and we expect it to go down, then do we think that this isn't like an accurate comparison? No, yes, yes, no.
I think so.
You think so? Okay, we have a yes here, and we have like a yes here. Do we have maybes? Do we have no's? I'm seeing more yeses than no's, so I'm gonna say this is another one leaning yes. C. Rate the experience of listening to construction noise as lasting for less time than it actually lasted. Yeah, I mean, like I'm seeing furrowed eyebrows, I'm seeing questioning, like, again, there's nothing about less time than it actually lasted. So that's not at all what we're actually talking about here. And then let's check D. Perceive the volume of construction noise. It never mentions volume, we can automatically. So this is the same problem that you're gonna see on most of these questions where you're gonna have two option choices that are kind of very similar, okay? So let's look. Again, we're looking for some kind of relationship, right? So we're looking for, if over here, break equals higher enjoyment, we're looking for something in these answer choices that says that with these breaks came lower enjoyment, okay? That's what we're trying to support, because we're trying to support the opposite conclusion. So we're trying to support a decrease in enjoyment. So let's look at A again. Find the disruptions more irritating as time went on. I'm seeing a lot of yeses. Oh, I'm seeing a yes, which is more than nothing. We don't have much time, so I'm gonna kind of like break like these two down. This one's a no, and the reason that it's not A is because we're not finding them more irritating as time is going on. We're finding them more irritating than if there were no breaks in the first place. But we're not finding it more irritating as time went on. We're not saying that, oh, at 29 minutes, it's like making people more angry than at the first minute they started playing it. That's not what the question is saying. The question is saying that, like here, where a break helped enjoyment, here, a break is worsening enjoyment, right? So it's not comparing to this first part of the sentence. Versus if we look at B, we say that when they had these breaks in between, they rated listening experience as more negative than those whose experience was uninterrupted. So this is exactly what A says, because A said that a break had an effect. This second sentence says a break, yes, it does have an effect, but we're looking for the opposite effect. This one doesn't talk about the breaks at all. And because the break is part of our finding, because we're saying that the break should have an effect in the first place, we don't care about what time happens. We don't care about what kind of effect time has. We care about what the breaks have. And these interruptions are the breaks. So if it's saying that we have a more negative experience, the more breaks we have, then this is the same exact stimulus as up here, but it does have the opposite effect. So this is the only one that actually gives us an effect of the breaks. Do we see why it's B and not A? Again, perfectly on time at 59, so I'm not gonna bother you guys more. I know that we breezed through that one. I would have liked to explain it better, but we don't have much time.
Okay,
So-
so before you guys leave, a little quick reminder again. Okay, please follow us on Instagram if you aren't already. We post updates through there, like little fun reels, resources. So if you haven't already, please follow us. Again, we're gonna be off next week, but we will be back on Wednesday, so please come back. Please, we'd love to see you here. Google Classroom, if you haven't already joined that. And please, we really want people to come join our team. If you haven't already, look to apply. You know, you don't have to be a minor student. You don't have to actively come to our school. If you just want to be a blog writer, you can just, do that remotely. You don't really have to be here. But definitely think about it. It's gonna end it ends next Monday. Okay? So just think about that. It's all on our Instagram. Okay? So that's all.
If you have any comments as you're leaving, feel free to let us know. So if you thought that we did something really good and that you want to see it moving next time, that's awesome. Let us know. Even if it's not related to our session. So if you thought something about the math, just let us know as well. Give us feedback. For what, the class? That happened essentially.
Well, yeah. Did Fabio make it that you had to have a fully reading? Hold on, give me a second, let me ask. Okay, but let me ask Fabio first, and then if anything, we'll get back to you.
Alright, thank you.
Fabio. No, because I wanted to talk.